Your relation is a set of ordered pairs. So if AB is an ordered pair of a relation, then BA is the inverse. So the range of a relation is the domain of the inverse, and the domain of a relation is the range of the inverse. So first one, find the inverse of this relation. So if the domain is -1 and the range is -2, then they just flip-flop. So if you made a table, then now your x is going to be -2 and your y is going to be -1, and your x is going to be -1 and your y is going to be 0. That's it. So you swap them if you have a set of ordered pairs. It definitely gets more complicated than that. So to find the inverse of a function, you're just going to flip-flop the x and the y. So it's going to be x equals y squared minus 2. In order to graph this, we're going to solve for y. So I'm going to add 2, and I'm going to take the square root. So y equals plus or minus the square root of x plus 2. So the original function, y equals x squared minus 2, is a parabola that starts 2 units down on the y-axis. And then you could graph it. Looks something like this. You could definitely be more precise. So that's the original function right here. And to graph the inverse, what you can do is you can reflect the inverse over the equation y equals x. So think about like actually rotating this. And so then the other graph would look like this. Okay? So or if you didn't follow that, just you could do a whole bunch of different ordered pairs on your parabola, on the original parabola. So let's pretend you had 0, -2, and you plugged in 1, and you got 1, -1, and you plugged in -1 and got -1. So therefore, your other inverse is going to be -2, 0, -1, 1, and -1, -1. So you could also flip-flop the ordered pairs. So is the inverse a function? Is this inverse a function? No, it is not, because this blue is the inverse of function. No, because the blue one doesn't pass the vertical line test. So the inverse, no. The inverse doesn't pass the vertical line test. Another way you can look at it as the original function doesn't pass what we call the horizontal line test. So it crosses twice right here, the horizontal. So the original function is going to be the horizontal line test. In the inverse, you're going to do the vertical line test. So off the bat, you could tell that the inverse is not a function. Okay, let's try B. So B, you're going to flip-flop the x and the y to find the inverse, and then solve for x, or solve for y, excuse me. So then I'm going to take the square root. So it's going to be plus or minus the square root of x plus 4 equals y plus 4. So it's going to be -4 plus or minus the square root of x plus 4 equals y. So the original function I'm going to graph in black again. So this is in vertex form. It's going to start left 4, down 4. And open up. Oops. You could be more precise. I don't have time for this to get in 15 minutes here. And then think about your equation y equals x. And you're going to reflect it over here. going to look something like this. So check out the original function. The original function does not pass the horizontal line test, but the vertical function does not either, so no, the inverse is not a function. And then the last one, let's flip-flop these. So x equals 3y. I'm going to already do the distributive property. So x minus 3 equals 3y. Y equals, divide each thing by 3. So it's 1/3 x minus 1. So this is going to be y equals 3x plus 3. So I'm going to go to 3x plus 3 on the y-axis. 3x plus 3. Oops. Okay, that's my original one. And my inverse was right here. And it makes sense because if I drew my line y equals x, look like this, and you could see that it's a reflection. So is this a function? Is the blue line a function? Yes, because the blue line passes the vertical line test and the original function passes the horizontal line test. So the inverse is a function. Sometimes we use this notation can be considered f inverse right here. So consider the function, find the domain and range of f. So the domain is going to be, you can't put all real numbers in there. So you need to have whatever is underneath this square root greater than or equal to 0. So 2x greater than or equal to negative 2. X has to be at least negative 1. That's the domain. So the range is, this looks like a square root function. So if I put my least amount for x to the left, so I'm going to put in negative 1 in for x, and I'm going to get the square root of 0, which is 0. So the range is all real numbers greater than or equal to 0. So if I'm going to find the f inverse, I'm going to switch the x and the y. So I'm going to have x equals the square root of 2y plus 1 plus 2. Square both sides. Subtract 2. And then divide by 2. So I'm going to have y equals 1/2 x squared minus 1. So this original one is half a parabola. It doesn't have the plus or minus in front. So the domain and range of f inverse is going to be these two flipped around. So it's going to be the domain is x greater than or equal to negative 1, and the range is y is greater than or equal to 0. So D, is this f inverse a function? Is this a function? Yes, because original function passes horizontal line test. That square root function up here passed the horizontal line test. Let's do the domain and range of here. So the domain is going to be, of this parabola is going to be all real numbers. And the range is, this parabola opens up at 4. So the range is y is greater than or equal to 4. So to find f inverse, this means f inverse. I'm going to flip around. First I'll write it like this. Then I'm going to swap the x and the y. Then I'm going to solve for y. So x minus 4 equals y squared. Y equals plus or minus, because we're taking the square root of the squared, x minus 4. That's a square root function. So the domain and range are just flip-flopped. So the range is x greater than or equal to 4, and the range is going to be all real numbers. I wrote it R instead, I meant a D. See, I took these two. Domain was all real numbers, so the range is all real numbers. The range is y is greater than or equal to 4, so the domain is x is greater than or equal to 4. Is f inverse a function? So f inverse is not a function because the original problem did not pass the horizontal line test. And then therefore the inverse looks something like this, and that doesn't pass the vertical line test. And then at the end, for the function f of x equals 1/2 x plus 5, find f inverse of f of 652 and f inverse of f of negative the square root of 86. Okay, you don't have to do all this work, because if you are finding the inverse and then the original problem, then what you're doing is just going to end up with what you started with. So inverses undo the original problem. So just like multiplying and dividing are inverses, if you multiply by 5 and divide by 5, you're back to the original number. So this function goes through 652 goes through the function, and then 652 goes through the inverse of that function. It's just going to end up being 652. So this answer is 652, and this answer is negative square root of 86. And then how do you find an equation that models the inverse of a function or relation if you have an equation x or y? What you do is you flip the x and the y around. So if your function was, I'll use f of x equals 2x plus 1. This is the same thing as y equals 2x plus 1. Now flip your x and your y. So swap your x and your y. So x equals 2y plus 1. And then solve for x, or solve for y, to graph it. So I'm going to write the notation f inverse of x equals 1/2 x minus 1/2 at the end. So this notation right here means inverse x, or inverse of f of x.